Is the sound still 100% fine?
Yeah, it's okay.
Okay or good?
Good.
Good.
Right. Okay. Right. Do you have, by any chance, have formulas with you? You go to the analytical geometry part in your textbook, you'll find all the analytical geometry formulas there. That's kind of important to have the formulas with you.
Yeah.
You've got it there. Okay, awesome.
Yeah. I still remember the formulas.
You still remember them. You know what's nice? There's basically nothing new. There's one or two things that we can consider as new, but it's not really brand new. So let me also quickly get that. Analytical geometry. And then I'm going to do some examples. I don't have it yet. I don't have the stupid formulas. Okay, so I'll get the formulas while we're doing the first example.
Isn't analytical geometry with hyperbola?
Okay, this is a system of axes. And I'm going to draw a line here. This coordinate here is A, and it is 3 and 6. And the coordinate B here is -5 and -3. I want you to do one. I want you to determine the length of AB. Can you give me the formula for the distance?
Root brackets x2 minus x1 close brackets plus
So
open brackets y2 plus y1 close brackets.
okay, you can have y1 minus y2 or 2 minus 1. It doesn't really matter. That is the distance formula. Instead of d, we're just going to use AB. Okay, quickly do that. Quickly do that. We'll do that together. I'm supposed to have the formulas here. I'll have to find a formula sheet for that.
So this is the formula for that.
Yeah. The answer I have is root 145.
And you always leave it in root form unless they ask you different. Okay, I'm gonna copy this is section out of your formula page to get those. Okay, look at this. This is all the formulas you need. This last one here is grade 12 circles. You're not going to use that in grade 10, grade 11. Good. Okay, let's quickly do it together. So both of you've got AB equals the root of the 1x value. Let's say -5 minus 3 squared plus -3 minus 6 squared. And the answer, please?
Root 145.
Your calculator will leave that as root 145. Yes. Good. Okay, so you could do this. This is like grade 10 work. Easy peasy.
Yeah.
All right, the next part that you need to be able to do is what? The gradient. Or they're just going to ask you, what is the equation of the line AB? And then you have to write y equals mx plus c. That you can do. That's peanuts. So your gradient is the difference in y values divided by the difference in x. But that both of you do know. Is that correct?
Yeah.
Ibrahim, speak to me.
Yes.
That's also really easy. It's just grade 10 work. Okay.
This is the
quickly.
formula for gradient.
Yeah, it's grade 9 even.
Is this the formula for gradient? That's mx plus.
Yeah, I have to do, look, unless they give me the y-intercept first. If I've got the y-intercept, then I don't even need to find the gradient. But because I don't have I don't have that, I need to find the gradient first. So you have to find the gradient first before you can actually do it. Okay, help me. It's like -3, -6 over -5, -3. Now,
Yeah.
is that 9/8?
Let me just recheck. Yeah, 9/8.
9/8. Okay. So from now, Abraham, I can only do the equation. Y equals 9/8 plus C. And then I just substitute any one of those coordinates. The 3 and 6 coordinate looks easy. The 6 equals 9/8 times 3 times C. That I just do with a calculator. I do 6 minus 9/8 times 3. I get 21/8. That looks right. So now I've got the formula. Y equals 9/8x plus 21/8. But again, this is grade 10. Let's do the last bit of grade 10 work. I want to know what is the coordinates of the midpoint. What's the coordinates of the midpoint? And the formula is m is x1 plus x2 over 2. y1. Fix that. y1 plus y2 over 2. Okay, I know this is going to bore you. We are going to do something better soon. Help. -5 plus 3 over 2. And -3 plus 6 over 2. And that is -1 and 3 over 2.
Yeah.
Is that good?
Yep.
So this is all easy stuff. Everything, and it's very important still. You are going to be expected to do all of the work we've just done. I'm just going to make this smaller. I want to bring in something new. Teach you one new thing. One of the formulas on your page is now tan alpha is m. This is for inclination angles. The inclination angle. Okay, so let's do a section on that. I'm going to do a new drawing. And I'm going to show you how inclination angles work. I'm going to do this. That coordinate is safe as -4 and -2. Let's make this P. And this one is R, which is 3 and 5. Okay. I want to know what is the inclination angle? Inclination angle of PRP or PR. Now, the inclination angle is the angle that the line makes with the positive side of the x-axis. So basically, you're going to draw with your eye, follow the line from the top until it meets the x-axis, and then go right. That's your inclination angle. So the angle the line makes with the x-axis, but the positive side of the x-axis to the right. So there's two angles, one to the right, one to the left. It's always the angle to the right. And you've got a formula for that. Tan alpha is m. M is gradient. So tan alpha is y2 minus y1 over x2 minus x1. Let's get that gradient. Who of you can see that the gradient is 1? It's 5 minus 2 over 3. 3 minus 4. And that's 1, 7 over 7. So that tan alpha is 1. And then you just type in, sorry, I can't speak with you. Then shift tan 1 is 45 degrees.
Yeah.
That's not difficult. Can you take a screenshot of that? That's very important.
Okay, take a screenshot.
Okay, let's do a line that's got an obtuse angle. Again, system of axes. And now I'm drawing a line. Let's make it red there. And I'm going to give this coordinate here. That's 4. And this one here at A is, let's say, 6 minus 3. Okay, now let's make this AB. What is the inclination angle of AB? Okay, look. I'm following the line from the top until it meets the x-axis, and then I'm going right. So that's the inclination angle. And you can see it's obtuse. It's bigger than 90. Obtuse is the right word, eh?
Yeah.
Okay. Good. So let's follow our formula. Tan alpha is m. Tan alpha is the gradient, which is y minus y over x minus x. Just make sure if you've written a 2 first, then you don't write a 2 again, you write a 1. And if you've written a 1 first, then it's 1, 2, 1, 2. Right, let's do that. Tan alpha is, okay. I just need to make sure that this is written in a coordinate. So that's 0 and 4. Okay, work with me. The one y value, let's use the top one, is 4. Minus the y value at the bottom is -3. The x value at the top coordinate is 0 minus 6. And that is 7 over -6. Now, very important. Type that in your calculator. Shift tan -7 over 6.
-49, 4.
Yeah, 3987, whatever. No. Okay, now very important. Your calculator obviously didn't give you that angle. This angle is what? Between 90 and 180. Your calculator gave you this angle here. Remember, your calculator doesn't know about this drawing. So it gave you the angle for tan closest to 0 degrees where it's negative. Because I have a negative, if you can remember something about trigonometry, because I have a negative ratio, tan will be in the first or fourth quadrant. So it will give you, second or fourth quadrant. It will give you a second or fourth quadrant answer. It's actually given you a fourth quadrant. So it just gave you this angle here, this one there. So how can I get the proper angle? Well, the difference between the sum of those two are 180 degrees. So I'm just going to do, therefore, alpha equals 180 minus 49,3987. I'm in fact, just going to add 180 to my calculator because I already have a -49 there. And then I get what? 30,61 degrees or something like that. So I just add plus 180. 130.
Yeah.
Just make sure you understand that.
Yeah.
Ibrahim, do
Yeah, I understand.
you want to do something harder than this? Is this too easy now? Or do you want to first?
Thank you, man.
Too easy.
Too easy.
Is it easy, Amira?
Yeah, I find it easy. But I feel like Ibrahim's being sarcastic.
No.
What do you mean? Is he not finding it easy?
I find it
It's
easy.
easy, I understand. I know. Understand what's cutting.
Right. I've got three coordinates there, A, B, and C. So I'm going to move the C so I can write it there. Right. I want you to find the angle theta. Make that drawing. Find the angle theta. And then think a minute about it. If you're not sure what to do, then you ask me to give you a tip.
Okay.
You're not sure what to do, then you say, okay, fine, phone a friend type of thing. Ask, you just give us one tip. If I only have to give you one tip, then you'll have it.
What you have to do, yeah. You have to get B, and then you have to get that D. Alpha.
You know what to do, Amira?
Yeah, Ibrahim doesn't know what to do.
I too have to get alpha.
Okay, Ibrahim, what? Guide me quickly, Ibrahim. Ibrahim, what were you gonna do?
You're gonna go M, and you're gonna use your formula there.
M.
Y.
No, I want a broader answer. How will we find that angle? That's not a inclination.
You're gonna use your formula that y2 minus y1.
You want to
over
use this
x2
formula. No. Look.
No, man. Y2 minus y1.
To do what? To get what? Which gradient do you want?
This one running down.
Okay, look at this. Look at this angle here.
Oh yeah.
That's the inclination angle. Look at that alpha. That's the inclination angle. I'm going to make it yellow.
Yeah. So
There's another inclination angle. I'm going to make it blue. And let's make that beta. Can you see that alpha equals beta plus theta, exterior angles of a triangle? Look, alpha theta plus theta. Alpha is beta plus theta, exterior angles of a triangle. Hello?
Yeah.
How can you write that short? Exterior angles of a triangle. There we go. Okay, so the first step is I want to find alpha. So this is the formula. Tan alpha is M. And I want to find beta. Tan beta is M. So you'll need the gradient of the yellow line and you need the gradient of the blue line. Go. Quickly work out the gradient of the yellow line. So tan alpha is y minus y over x minus x. And then you're going to do the same. Tan beta is y minus y over x minus x. Get those two answers. I want those two angles. You've just done it. You should be able to get those. Quickly do those two angles.
For beta, it's 3/10.
Okay, I just want to fill in the values. You did 8 minus 2, the y's, and the x's are minus 1 minus 4. So I've got 10 over 3.
Okay, I did y2 minus y1, so that's how come it's off.
It doesn't matter.
Way.
It doesn't matter.
Okay. And for the yellow one, I got negative 3/8.
So tan alpha is 8 minus 0. But no, you swapped your x and y values around.
Yeah.
So tan alpha is 8 over negative 3. Okay, good. So now let's work with alpha first. Shift tan 8 over negative 3. What is that?
That would be negative 69,4439.
But that's impossible because it's between 90 and 180. So I'm just adding quickly 180. Then I get 110,556. Is that correct? Do you understand?
How
what
did you get that?
No understand.
How did you get the 110?
Okay, let's just do shift tan 8 over negative 3. And then you got minus 69,443.
Yes.
But that's this angle here. It is the negative side of that angle. In other words, I'll explain it again. I'll do a use one again. That your calculator didn't give you this yellow angle. It gave you the pink one. And that angle is negative 69. So I'm just going to add 180 degrees because this is a straight line. Can you see that?
Oh, okay, yeah.
So I just added 180 in my calculator. My calculator then did 180 minus the 69 and gave me 110. Remember that angle must be anywhere between 90 to 180 degrees. It can't be anything else.
Okay, yeah.
Okay, this is only when it's obtuse. When it's acute, like the blue angle, you'll find a positive answer straight out. So shift tan, the blue one, is 10 over 3.
So whenever we get the negative answer, we must just put 180.
Then
Plus
you have
180.
obtuse angle will always start with a negative answer first.
Oh, so then we just add 180, then we're going to get a positive.
Yeah. We're going to do one like that just now. So that's 73,3. And then I'm going to do theta equals alpha minus beta. Then I have 110,556 minus 73,3, and that is theta. So 110.5 minus the answer, 37,26. Okay, let's do a new example. Screenshot this. This is important. Right, let's do a new one. Just an obtuse one again. Okay, here we have a coordinate of -6 and 2. Let's make it A. And there we have a coordinate B. It is like 4 and -3. I want to know what's the inclination angle of AB. Okay, I'm just going to draw it in. It's you start on top, and the minute you hit the x-axis, you go right. So that's we can call that alpha if we want to. That's the inclination angle. So whenever it's obtuse, whenever your gradient is negative, you're going to have a negative answer and you have to fix it. Because my calculator is going to give me the answer of this dot, that angle. So now we're going to write the formula. Tan alpha is M. So tan alpha is y minus y over x minus x. Tan alpha. 2 plus minus 3 or 2 plus 3 divided by -6 minus 4. And you can just, you don't have to get an answer for that. You can just shift tan and all that calculation. That's 5 over -10. So you're going to get a negative answer. Shift tan. 5 over -4. So I get -26,565. So what is alpha? Alpha is 180 minus that angle. And you're going to just add 180 to your calculator. 153,343. Is that cool?
Yeah.
Now you can. Okay, one more thing. That application of one of the things that you've learned in grade 10. There's a line. And I've got the midpoint of that line is at 2 and -1. I have a coordinate D there, which I don't know. And I have a coordinate B here, which is -3 and -8. I want to know what is the coordinates of D. BM equals DM. Or you can say M is the midpoint of the line. What would the coordinates of D be? I want to know what would the coordinate of D. Okay. Just look at that. Who of you can figure that out?
If I'm not mistaken, you'll say for the first one, 2, which equals to x plus -3
Okay.
over 2.
Yeah. Okay. So there's two ways of doing it. There's two ways of doing it. Method one is algebra. Method one is algebra. So I'm going to use the midpoint formula. The 1x plus the other x divided by 2 give me the x in the middle. So your midpoint formula looks like this: x1 plus x2 over 2 and 1 plus y2 over 2. So look at this. X1 plus x2 over 2 gives me the x value in the middle. So the 1x is there. I don't know what it is. It's just x. Plus the other x is that one, -3. Divided by 2 gives me the x value in the middle, which is 2. Now I multiply with 2 right through. X minus 3 is 4. Therefore, x is 7. Are you with me?
Yeah.
And then I'm going to do exactly the same with the y value. The 1y plus the other y over 2 gives me the y value in the middle. The 1y is just a y. The other value is -8. I divide that with 2, it gives me -1y value. I multiply with 2 through. I get y minus 8 is -3. Y equals 6. So the D coordinate is 7 and 6. So please do that. Or write it down.
Okay, I got it.
Not write it down. Tell me when you're ready.
Ready.
Okay, then there's another way of doing it. It's through transformations or through inspection. Look at this. Look at this movement. I'm going from B to M. I'm going to the right from -3 to 2, which is 5 steps. You see that?
Mhm.
I'm going down from -8 upwards. From -8 to -1 is upwards 7 steps. Then I'm going to do exactly the same. I'm going from a midpoint to the right again with 5 steps, and I'm going up again with 7 steps. Now, from 2 onwards, 5 steps gives me to 7. So the x coordinate is 7. Then from -1, 7 up gives me 6 steps, or gives me +6. And that's the D coordinate, and that is inspection. Is that easy?
Yeah.
That's easier, I think.
Yeah, it's easier. It's easier, except when there's fractions. Then it's kind of harder to measure and see, okay, what? Then the algebraic method is sometimes easier. But you have to be able to know about both. Right. Okay. One more thing. Because I'm going to assume that you're going to work now. Let's start here with the drawing. The most important shape or quad that you're going to learn is a parallelogram. Now, parallelogram, you're going to work with quadrilaterals also. Parallelogram, both opposite sides are parallel. Okay, they're also the same length. But we're not going to use, in analytical geometry, you don't need any one of those rules. Why? Because imagine you've got a quadrilateral and you have to prove that it's a parallelogram. Then you have to work out 4 side lengths or 4 gradients. Both opposite sides are either equal or parallel. What is very helpful is the following. So we're not going to use this. We're going to, with parallelograms, you're only going to use one rule. And that is that these lines bisect one another on the same spot. So the midpoint of the line, they are equal. And D and C midpoint is exactly on the same spot. So the midpoints of the bisectors are equal. So in other words, if you have a parallelogram and you work out what is the midpoint of AB and you get a value, that must be the same as the midpoint of CD. If the midpoints are the same, then that is the parallelogram. So if you have to prove that something is a parallelogram, then you only have to work out 2 midpoints instead of either 4 lengths and 4 gradients. So just keep that in mind. We haven't done any of that, but just keep this in mind. If you have to prove something is a parallelogram, you are going to work with midpoints of the bisectors, not, otherwise you're going to have too much work. Okay, let me just see what I can actually forward to you now. What work have you completed that I haven't sent you any homework on? Is that correct?
But, sorry, I couldn't hear you.
Sequences.
Sequences, yeah.
So nth term. Did we do that?
Yeah.
We did do that.
Okay, that I'm going to send on the group. I want to test this group as well, because sometimes I'm not sure if you actually get the work. So this is your grade 11 TET group. I'm going to send you something on sequences, number patterns 1. It's just called number patterns. There's 2. Wow, there's 3. This is a lot of work, actually. Eh? Let's just do 2 of them. Okay. It's not long tests. They're like 4 or 5 questions max. So I want you to do these as well. I'm sending you now. So I'll send you three sheets of homework to do. And you have to fill in the answers online. And then when I see you again, we discuss some of the stuff that you couldn't do. Like say, for instance, you're finding something on this number pattern test now that you have actually no clue.
Okay.
Then you don't fill in the test. You wait and I'll explain it to you. Okay.
Okay.
Right, we're finished. We will spend more time on analytical geometry next week. There's some quadrilateral stuff. And then we'll go on to other work.
Okay. Thank you so much.
Bye.
Bye.